So we're going to be discussing the microcirculation as well as the Bicarb buffer system and those pathways in an effort to explain how we keep our body's pH in homeostatic ranges. Now the first thing I want to discuss are the two different types of pressure that we actually have. We have hydrostatic pressure as well as osmotic pressure. Now, hydrostatic pressure is us pulling O2 and nutrients from our blood into our cells. We know that the pressure in our arteries are going to be significantly higher than the pressure in our veins because our veins are so much farther away from our Then we also call it osmotic pressure. Now, call it osmotic pressure is the pressure exerted from the proteins such as albumin pulling substances from our muscle or tissue cells into our blood. So we go this way. Let's take, for example, we're going to be exercising. What is going to come out of that? Well, first of all, our body's pH is going to go down significantly because we're going to be in an acidic state. The CO2 is extremely acidic. Our body temperature is going to increase. Our CO2 levels are going to increase. And we are also going to have a DHG, excuse me, that also increases. Now, this tells us directly that we need to incorporate the Bohr effect. Why do we need to do that? Because our body right now is in an acidic state and we are at risk of acidic acid or respiratory acidosis. How are we going to combat this? Well, we have three ways to get rid of the CO2 that is now in our blood. We can put 7% of it directly into our plasma, which we don't want because it's still going to keep it acidic. We have 23% of it, which is going to go directly behind our hemoglobin, so it's going to lower the affinity for our hemoglobin, but by making it deoxyhemoglobin and put it into a tense state. The last thing that we can do is put 7% of it into the Bicarb buffer system to make Bicarb directly. What that's going to do is we're going to take the CO2 and H2O from our blood and we're going to combine it to make carbonic acid. Now we're going to combine this with carbonic anhydrase to make Bicarb as well as proteins. This Bicarb, once again, 70% of it is going to go into our plasma, but these protons are actually going to combine, or they're going to bind to the histone residues of our red blood cells. Now, what does this mean? This means that we are going to be flipping the roles of this a little bit. We are going to actually be increasing our pH, decreasing our body temperature, decreasing our CO2, and decreasing our DHG. The reason for this is because our body's telling us to go into the haldane effect, which is going to flip it and reverse it. This is because we want to increase our body's oxygen affinity, and we want to bind oxygen to the hemoglobin to make oxyhemoglobin and put us into a relaxed state. How are we going to do this? We are going to take those histone residue protons that we have, and we're going to pull Bicarb from our blood, and we're going to combine them to make carbonic acid. Now we're going to combine carbonic acid and carbonic anhydrase to make CO2 and H2O, which we then can expel out of our body